What are common NASCAR suspension geometry setups? Have you ever wondered how NASCAR cars manage to stay so stable while racing at incredible speeds? The answer lies in their suspension geometry. Let's break down what makes these setups so effective on the track. NASCAR cars typically use a solid rear axle suspension. This means both rear wheels are connected by a rigid axle that moves together. This design is different from the independent rear suspensions found in many other racing vehicles. The solid axle is mounted on a frame that connects to the chassis through a gimbal joint. This allows the suspension frame to roll, pitch, and yaw as the car navigates the track. To control these movements, the suspension frame connects to the chassis using two spring and damper struts along with a Panhard arm. The Panhard arm, also known as a track bar, helps manage the lateral movement of the axle. This setup is essential for maintaining stability during high-speed turns. When it comes to the front suspension, NASCAR cars often utilize a double wishbone or A-arm configuration. This design allows for precise control over wheel movement and geometry changes as the suspension travels. Now, let's talk about some key geometry parameters. Camber is the angle of the tire when viewed from the front or rear. NASCAR setups usually feature negative camber on the front wheels. This helps improve the tire contact patch during cornering, especially as the car leans and the suspension compresses. Next is caster, which is the angle of the steering axis when viewed from the side. A positive caster angle enhances straight-line stability and steering feel, which is vital for controlling the car at high speeds. Toe refers to the angle the tires point inward or outward when viewed from above. Adjusting the toe can significantly impact the car's responsiveness during turns and how the tires wear over time. Ride height and spring rates also play a role in how the car behaves in corners. NASCAR setups often balance stiff springs with low ride heights to minimize body roll and keep consistent tire contact with the track. The position of control arms, also known as A-frames, is crucial for how the wheels move through their travel arc. Shortening the upper control arm compared to the lower one can create more negative camber gain as the suspension compresses during turns, which enhances grip. NASCAR teams customize their suspension geometry based on the type of track and the driver's style. For instance, on high-speed oval tracks, the focus is on stability and minimizing body roll. In contrast, shorter tracks may require more aggressive camber adjustments and softer springs to improve cornering. The rear solid axle setup with the Panhard arm is specific to NASCAR's Generation 6 cars, which were used until 2021. This design aims to provide predictable handling despite the rigid connection between the rear wheels. In 2022, NASCAR transitioned away from the Generation 6 suspension, but the principles of controlling axle movement through geometry and linkages remains essential. Adjustments to front suspension geometry are critical for maintaining a consistent tire patch and slip angle, which directly influence grip and tire wear during a race. In summary, NASCAR suspension geometry setups are all about controlling wheel angles and movement. By combining solid rear axle linkages with precise front double wishbone arrangements, these setups maximize tire contact and handling performance for the unique demands of oval track racing.